Welcome. So today I'm going to be trying to solve this problem. So I'm going asked to find the integral of x cubed natural log of x dx. So many of you who have been doing calculus for a while now will think that, oh, I'm going to be using integration by substitution perhaps. In this case it's different. We're going to be using integration by parts. What is meant by that is that I'm going to divide the sets into two chunks, into two pieces, and try to figure out how to find the integral, which is this sign right here. Sorry, this keeps on repeating. Right, this sign here is the integral. We have a formula for that. The formula for integration by part, it goes as follow. We have the integral of u times derivative of v, because this is part, like as I say, it's parts. So this we have part A and part B. So one is partial, so right now one is already different. We'll find the derivative, but here we're going to find the partial integration by parts. So sorry if I'm mixing words. So this is equal to u times v. I'm going to try to put my v like that, minus the integral of u, oh no, sorry, of v, oh gosh, of v times the derivative of u. So this is the equation we're going to be using. This is the formula we're going to be using, my apologies, to solve this equation, to solve this. So now, first step, after finding the formula that we're going to be using, we want to figure out which one of these two between x cubed and natural log of x is going to be our u, and which one is going to be our dv. If I look at this, it will be easier for me to have natural log of x as being my du, my dv, because once I take the integral, when I take the antiderivative of natural log of x, I'm going to be ending up with 1 over x, which is easier to work than trying to find, than putting natural log of x as my u in this case and trying to find the derivative of u. That is a lot. So my advice is to always try to make sure that the one that are easier to work on, for example, if I was given e to the power of x or e in general, it would be easier for me to work using e and natural log of x than having to work with x squared and x cubed, taking them as being my dv. So that being said, I'm going to start by figuring out the missing components. So I know that my u is going to be x cubed, and my dv, sorry, is going to be natural log of x. So taking the derivative of u, I will end up, with respect to x, of course, I will end up with 3x squared. And taking the antiderivative of dv, that means that I'm going backward. I'm going to end up having v as 1 over x. Perfect. With this information, I know that I can easily substitute all of those components, my apologies, all of those components inside of this formula that I have in order for me to solve this problem. And that's what I'm going to be doing right away. So knowing that, I can write this down here using now what I know. So I know that u is x cubed. Just going to write it down here. And I know that my v is 1 over x, so I'm going to multiply it here, minus the integral of v, which once again I just found was 1 over x, times the derivative of u, which is 3x squared. Of course, this whole thing is with respect to x. Right? Perfect. So, I can simplify this as x cubed over x minus the integral of, when I multiply this, I end up with 3x squared over x dx. Going further down the line, I can simplify x cubed and end up having x squared. And on the same idea, my apologies, I'm going to end up with, on this side, if I simplify the x squared and x, I end up with 3x dx. Perfect. So this is a easier thing to work with, because now I have x squared on one side minus the integral of 3x dx on the other side. So what is the antiderivative, or the integral in this case, of 3x? That is easy. I can just come here, 3x, which is normally 1 to the power of x to the power of 1. If I add another, and take the antiderivative, that means that I'm going backward. I'm going to end up adding a 1 here, and then this whole power is going to be the one I'm going to be using down here. So I will end up with 3x squared over 2. So this is the antiderivative, or the, in this case, the integral of 3x dx. I'm gonna erase this and then write it down here. So I end up with x squared minus, now I have, what was it again? It was 3x squared over 2. Of course, because I'm taking an indefinite integral, I think, so I'm going to be adding c, because I don't know if when I was taking the integral, there was a c there. So this is my final answer. I hope this helped. Have a nice day.